All right, geometry. So here's our first problem. It says graph and label the quadrilateral with the given vertices. So you're going to use this polygon tool right here. All right. So we're going to start with A at 0, 0. Okay. And then B is at 5, 5. Good. C is at 8, 4. And then D is at 7, 1. And then you have to make sure you connect it back to the beginning to create your shape. And again, you got to make sure you're graphing it correctly, right? So it's X first, Y second. Remember, again, I hate that I have to keep telling you this, but all of your points are X first, Y second. And remember, that's left and right first, up and down second. Okay? All right, so that's part one. So then part two says, based on the graph in part A, predict the most precise name for this quadrilateral. So if I'm looking at this, I think that's a kite. So I have a drop-down menu with all the special types, so I think it's a kite. Okay, so if you think it's a kite, now in step 3, you need to use the slope and distance formulas to show that the quadrilateral is the predicted name from part B. You can use math type, which is that square root button right here, or just plain type, and I'll do both ways to show you what I mean. So let's do math type first. So first of all, if you look at that hierarchy, you need to show that there are no pairs of parallel sides. So if I come in here to math type, all right, I can do M for slope, and then say we're going to find the slope of AB first. Now, I'm going to cancel that for a second because I actually have to find the slope of AB. To find the slope, we're going to count rise over run. So here's A, here's B. I always like to go to the right. So I'm going to go from A to B going up. 1, 2, 3, 4, 5, up 5, and then right. 1, 2, 3, 4, 5. Okay. So my slope for AB, I'll come down here. So in math type, slope of AB is going to equal 5 divided by 5. And that actually simplifies, right? 5 divided by 5 simplifies to 1. So again, make sure you do that. Now, the other way I could have done that is I could just do this, the slope. And let me do this real fast. Let me go ahead and put slopes right here, slopes. Okay. If you forgot the M in front of the AB, that'd be okay. I would not take off points. You could also just put slope of AB equals 5 divided by 5, which is 1. I don't care how you do it, right? I'm just showing you math type versus plain language. Okay, so maybe I'll put that over here. Or you can do it this way. Okay, whatever you want to do. I'll keep using math type, so let's go back up here for BC. So to get from B to C, I have to go down 1 and right 3. Again, to go from B to C, I have to go down 1 and right 3. So that's a slope of negative 1/3. So slope of BC equals negative 1/3. And that simplifies to just negative 1/3. Done. Okay, now we'll do CD. So to get from C to D, again, I'm going to count from D to C because I want to go to the right. That is up 3 and right 1. So that's 3 over 1, positive 3 over 1. So we're going to go back into math type here. Slope of CD equals 3 divided by 1, which is just 3. And then last but not least, we'll do A to D. So if I do A to D, I'm going to go from A to D. I'm going to go up 1 and then right 1, 2, 3, 4, 5, 6, 7. And to the right 7. That's plus 7. So that's 1/7. So the slope of AD equals 1/7. Now if I look here, notice that all of your slopes are different. None of them are the same, so we have no pairs of parallel sides. So now you need to show me that the consecutive sides are congruent. So to do this, we're going to use the distance formula in our rises and runs. So watch. So in this, I'll do AB equals, so these are lengths. So AB equals the square root, right there. And it's going to be 5 squared plus 5 squared. Where do I get the 5 and 5 from? From the slope of AB. It's the unsimplified slope. 5 over 5. 5 squared plus 5 squared is 50. So this is the square root of 50. And if you type in the square root of 50 in your calculator, it does not simplify. It's like 7 point something. So just leave that alone. Now you could also do this. AB equals. So we could do square root. What button could we use? I'm not really seeing a good square root button. So maybe you could do SQ. Yeah, SQRT for square root. So square root of. If you want to do it like that. So it'd be 5 squared plus 5 squared. That equals the square root of 50. Okay, I don't care how you do it. I just want to make sure I see it. Okay, let's do the other sides now. So again, we're just going to do BC now. We use the rise and run underneath the square root. So the rise was 1 and 3. So 1 squared plus 3 squared. Notice I'm not using the negative. Don't use the negatives. 1 squared plus 3 squared is 10. So that is the square root of 10. That does not simplify either. It's not a nice number. So just leave it alone. CD equals. So we have 3 and 1. So that's going to be the square root of 3 squared plus 1 squared. That is also the square root of 10. So look at that. I got a pair of sides that are the same. Okay, and now let's do AD. So AD equals the square root of, and it's 1 and 7. So I have 1 squared plus 7 squared. Let me go back to that. Notice, watch, when I do the squared, notice if I don't press the right arrow, notice it just keeps going up at the top. You don't want that to happen, right? So press to the right once, plus 7 squared. 1 squared plus 7 squared is 49. So this is the square root of, or, I'm sorry, 1 squared plus 7 squared is 50. So that is also the square root of 50. It does not simplify. And there we go. Does that simplify to a nice number? So what did I just show? I just showed that segments, now look where I get the segments, segment AB, arrow to the right, is congruent to, so that's in the symbols here, segment BC. I'm sorry, segment AD. And you could also just type it in, and segment BC is congruent to segment CD. And where are these two things at? So if you look at the picture up here, A, B, and AD are consecutive sides, and so are BC and CD, which are your two that are linked. So we just showed that we have two pairs of consecutive sides congruent. And that makes this a kite. And that's how you're going to submit the problem. Good times, right? Okay. So again, so those are the slopes. If you want to put down like the lengths here, I don't care what you want to do. Okay. But again, this better show me why it is the figure that you think it is. All right, good. I got 2 more of these.